Hello, YouTube community. Greetings to you all. I'm once again Elisa, back to take you through online mathematics. So today we're going to talk about the independent events. Picking up from the previous lesson, we talked about the conditional probability. So from conditional probability, we're going to talk about the independent events. What are independent events? Okay, to understand independent events, okay, we must understand conditional probability. You know, in conditional probability, the occurrence of one event affected the occurrence of the other. But in independent events, the occurrence of one event will never affect the occurrence of another event. Let's write down some information. So we can say that if either of the events A and B, okay, can occur without, that is it about independent events. If either of the events A and B can occur without being affected by the other, then the two events are independent. The occurrence of one event does not in any way affect the occurrence of another event. It's like the example we can give here. If a couple is having a child, the firstborn is a girl, okay? It will not affect their chance of the secondborn being a girl, no, okay? The firstborn is a girl does not affect the chance of a secondborn being a girl, no, because they are born independently. Or if you didn't have lunch today, that won't affect Qatar Airways from taking off Entebbe Airport, and those are independent events. Totally, the occurrence of one event does not affect the other event. Okay, they are independent events. Okay, or if look at this situation, you have been given a chance to select money from a bag. They are dollars and shillings. Okay, and you have been told that you pick, take a look, and put back. If you pick the first time a dollar, okay, it won't affect picking a shilling the second time. No, those are independent events. But if we are picking and not putting back, then they will be conditional. Okay, so let me help you understand what we mean by independent events. So the other thing we can write about independent events is if A and B are independent, then P of A given B has occurred, okay, is precisely, okay, is precisely the same as P of A, since A is not affected, by B, okay? So, we talked about this in a conditional probability, probability of A given B, okay? We are saying that this is precisely a probability of A, okay? As long as the events are independent, the conditional does not apply, okay? Much as B has happened, whether it has happened 1,000 times, it won't affect A from happening, no, okay? So, it is also true that probability of B given A will be probability of B, because occurrence of A does not affect B, okay? But there's something we know about, there's something we lived. We said the probability of A intersection B. You remember, this was picked, okay, we left this in conditional probability. Probability of B given A, okay, times probability of A. Okay, we talked about something like this last time, probability of A, which is the same thing as actually probability of A given B times probability of B. Those two are the same because the two give you the intersection. So let's work with one at a go so we can understand what we are trying to learn. It's something very simple. Okay, so let's work with this. First, let's use the first one. Okay, or let me erase, and since people prefer to begin with A and then go to B, let me write this as the probability of A given B times probability of B. Okay, but we are saying that probability of A given B from this step up here, the probability of A given B is probability of A. So this will be equal to probability of A times the probability of B. Okay, I think it is clear because the occurrence of B has not affected A, so this probability here is precisely P of A. When you substitute, you end up with P of A times P of B. So to get the intersection in an independent event situation, you multiply the respective probabilities. Let's write it perfect on next page. So we have tried to write everything so well so that the information is clear to anyone reading this. The probability of A intersection B, okay, the same thing as the probability of B intersection A, which is P of A times P of B, this part, P of A times P of B. So in the independent events, to get the probability of the intersection, you're going to multiply the individual probabilities, okay? And this and this are exactly the same things, okay? And that's what we call the AND rule in multiplication, the AND rule in independent events rather. So about that, okay? Yeah, remember what we talked about in mutually exclusive events. We talked about the OR rule where the union was just the sum of the probabilities. So here, it also happens in independent events. The probability of the intersection is the same thing as the product of the individual probabilities. So that's what we call the AND rule, okay? In probability, it applies to only independent events, only independent events. Do not multiply probability to get intersection of two events if they are not independent. Don't make that mistake, okay? This is so important. Now, let's talk about, let's write down some more information about this that is going to be useful for you. So what else do we need? We can see that there are three conditions. So there are three conditions for A and B to be independent, and any one of them may be used as a test for independence. Okay, there are three conditions. And what are the three conditions? These are the conditions. I will highlight them here so they are so clear to you. The conditions are, okay, the probability of A intersection B is probability of A times probability of B. The probability of A given B is precisely the probability of A, and the probability of B given A is the probability of B. So you could use any of these to test for independence. Okay, it's not really so hard. Any of these could be used as a test for independence, and if one is satisfied, the others will also be satisfied as well. So this is something that you can always do, but it is important to learn this. Okay, I wanted to give it to you so that in the future, when you find problems about independent, question about independent events, you can easily go about them. What else do we need to know? This multiplication law does not only apply to two events A and B, but it applies to n of them. If you have n events that are independent, to get the intersection, you're going to multiply the probability. Maybe I write it for you down. Okay, let's look at an example. Here. It says a fair die is thrown twice. Now the question is, find the probability that two fives are obtained, rather. Okay. Now, there's something you have to know about a die. If it is fair and ordinary, then it gives equal chances to all of faces to show up. Okay. So, on one throw, okay, the probability of the probability of getting a 5, is 1 out of 6, because any ordinary die has 6 faces. So if it is fair, it gives equal chance to each face, and therefore the probability of getting a 5 is 1 out of 6. Okay. What happened is, on 2 throws, okay, that's now throwing the second time, the probability of 5, okay, the first time, and the 5 the second time, will be probability of 5, okay, first time, times probability of 5 second time. But remember, 5 first time is 1 over 6, and the second time is 1 over 6, because these are independent events. Getting a 5 the first time won't affect the chance of getting a 5 the second time. So this 1 out of 36. And therefore, the probability that 2 5s are thrown is 1 out of 36. Example 2. Events A and B are such that they are independent. That's the key word in solving this problem. The events are independent. So they are saying that the probability of A is 0.3 and probability of B is 0.5. Then probability of A intersection B. For independent events, this is simply probability of A times probability of B. Okay, you have 0.3 times 0.5 equals to 0.15. Okay, and that is it. As simple as that. It is a very simple problem. So they are saying probability of A union B. This is probability of A plus probability of B minus probability of A intersection B. Remember, we talked about the probability rule for combined events. That will always give you the union of any situation. This is very important. So, what is the probability of A union B? This is A 0.3, okay, plus B 0.5 minus 0.15, okay. What's the answer? That is 0.8 minus 0.15 to get 0.65. That's the probability of A union B, okay. So they are asking, are A and B mutually exclusive? Okay, the answer is A and B, since probability of A intersection B is equal to 0.15, which is not equal to 0, okay. A and B are not mutually exclusive. They are not mutually exclusive. You know what determines mutually exclusive event is the intersection. If it is zero, then the events are mutually exclusive. Look at this chicken and egg problem. Why chicken and egg problem? Because everything is just obvious. So they are asking for probability of A given B, but they have mentioned that the two events are independent. Okay, and we say that for independent events, the probability of A given B is precise the probability of A, which is 0.2. Okay, then that's part A. Part B, probability of A intersection B for independent events. This will always be probability of A times probability of B. And if you get a probability of A, which is 0.2, multiplied by 0.15, then you are going to get the probability of A intersection B, which is 0.03. Okay, so the probability of A intersection B is 0.03. Then C, they want you to get the probability of A union B. Remember, we get this from the probability rule for combined events. This probability of A plus probability of B minus probability of A intersection B. Okay, when you get your A, which is 0.2, plus B, which is 0.15, minus 0.03. Okay, the answer will be 0.32. That's the probability of A union B. Okay, if my answer is not correct, please get a calculator and do it, because I'm just purely using my head. So I think that is okay. Okay, one more example. So let's look at this last example in our discussion today. The probability that a person in a particular evening class is left-handed is 1 out of 6. From a class of 15 women and 5 men, a person is chosen at random. Okay? Assuming that left-handedness is independent of the sex of the person, find the probability that the person chosen is a man or is left-handed. Now let's try to use some letters to stand for the events. We shall use L to mean person is left-handed. Okay, person is left-handed. Okay, meaning that the probability of L is 1 out of 6 given. We shall use M to mean person is a man. Okay, this means that the probability of choosing a man from this evening class is the number of men, okay, from a class of 15 women and 5 men. So they are 5 out of 20. Then we shall use F, okay, to mean that, and this is the probability that a person is a woman. So P of F, let me use F is 15 out of 20. Now, they are saying find the probability that a person chosen is a man or is left-handed. P of M or L is P of M plus P of L minus P of M, okay, and L. But no, this is an independent situation, okay? The probability of a man, 5 out of 20, plus 15 out of 20, minus 5 over 20 times 15 out of 20. Okay, so because the independent, it's an independent situation, to get the intersection of M and L, we multiply. Okay, oh no, this is not 20, but it is 1 over 6. Let me, sorry about that. This is 1 out of 6. 1 out of 6. So what do we get? If you go ahead and do your mathematics, this is gonna be 1 minus 5 out of 120. 5 over 120. So what's the final answer? It is 115 divided by 120. You can reduce by a factor which will favor it, but that is it. 115 divided by 120. Oh, my dear ladies and gentlemen, thank you for listening to me and trying to learn from my YouTube channel. I appreciate that. I would just request you to always subscribe, okay, and share this information with your friends, because the more views I have on my channel and the more subscriptions determines if in the future you'll be given something from YouTube community. So I would request you to encourage a friend, to encourage a friend, to encourage another friend, to encourage a friend, up to N, okay, friends, to subscribe. And when you subscribe, don't forget to click on the notification bell. That way, if I upload a new video, you'll be notified instantly. Thank you so much for listening, and I wish you the best. That's it for today. Thank you.